So just imagine this for a second. It's 1977, late at night. You're sitting in this quiet room, right? No phones, no internet, nothing like that. Just machines. Big ones. Like the kind that make noise for no reason. And your job? You're literally listening to space.
Which already sounds kind of crazy when you say it like that.
Yeah, like if you told someone today, hey, I get paid to listen for aliens, they'd be like, okay.
Yeah, bro, take a break.
Exactly. But back then, this was real science. Researchers were using radio telescopes to scan the sky, picking up signals from deep space. Most of it was just noise. Static, random signals. Nothing interesting.
Yeah, space is actually really noisy in a boring way. Like, people think it's quiet, but in terms of radio signals, it's just constant background stuff.
Exactly. So most nights, nothing happens. You just collect data, print it out, and move on. But then, one night, something different shows up.
And not just a little different. Like, the kind of different where you stop and go, wait, hold on.
So this all happens at a place called the Ohio State University Radio Observatory. They had this massive radio telescope called the Big Ear Radio Telescope. And the whole goal was simple. Scan the sky and look for signals that don't belong.
Like, something that isn't natural.
Exactly. Because if intelligent life existed out there, they wouldn't just show up randomly. They'd probably send a signal. Something structured. Something intentional.
Something that stands out from all the random noise.
Right. So on August 15th, 1977, the telescope picks up a signal. Now at first, it's not like alarms go off or anything. It just gets recorded like everything else. Numbers, letters, printed on paper.
Yeah, this wasn't like a movie where everything starts flashing red.
Not at all. It's literally just a printout. And a few days later, an astronomer named Jerry R. Amon is going through the data, just reviewing it like normal.
And then he sees it.
Yeah. He sees this one section that just looks off. Like it doesn't match the rest.
Because instead of random numbers, there's this sequence, 6EQUJ5.
Now, to most people, that looks like nothing. But what that actually represents is signal strength over time. And this one, it spikes perfectly.
Like way higher than anything around it.
Yeah, and not just random high. It rises smoothly, hits a peak, and then drops. Exactly how a real signal from space would behave if Earth rotated past it.
Which is the part that made everyone pause. Because that pattern, that's not what random noise looks like.
Not at all. So Jerry sees this, circles it with a pen, and next to it he writes one word. Wow.
And that's literally how it got its name.
No committee, no official naming process, just one guy being like, wow.
Honestly, valid reaction.
Very valid. But here's where things get even crazier. The signal lasted 72 seconds.
Which is long. Like, that's not just a quick glitch or a random spike.
Exactly. It's long enough to confirm it's real, long enough to confirm it's real, but still short enough to disappear.
And that's the problem.
Yeah, because after those 72 seconds, nothing.
Gone.
Completely gone.
They never detected it again. Not the next day, not the next year, not ever.
And that's what turns this from interesting into, okay, wait, what was that?
Because think about it. If it was natural, you'd expect it to repeat.
Right. Stars don't just blink once and disappear.
And if it was something from Earth, you'd expect to track it.
But this happened once. Clean, strong, perfect. Then just vanished.
And that leaves scientists with a really uncomfortable situation.
Yeah, because they have real data, a real signal, recorded, analyzed, but no explanation.
And science doesn't like that.
Not at all. Because if you can't repeat something, you can't confirm what it is.
So now you've got this signal that looks intelligent, acts like a real transmission, but gives you nothing to follow.
No direction, no origin, no second chance.
Just 72 seconds. And a question. What did we just pick up?
Because whatever it wasn't normal.
And that's where the mystery really begins.
So now you've got this signal sitting on paper, right? 6EQUJ5, 72 seconds, strong, clean, and, no idea where it actually came from. And the first thing scientists do is try to rule stuff out. Because before you even think about anything crazy, you check the obvious.
Yeah, like step one is always, could this be from Earth?
Exactly. Satellites, airplanes, military signals, random interference, all of that. And they go through it one by one. And nothing matches.
Which is already weird because usually when something shows up like that, there's a simple explanation.
Yeah, like 99% of the time, it's just something normal you didn't expect. But this time, nothing lines up.
And then there's the frequency.
Yeah, this part is actually really important. The signal was detected at around 1420 megahertz. Now that might sound random, but it's not.
That frequency is known as the hydrogen line. Basically, it's tied to hydrogen, which is the most common element in the entire universe.
So if you were, hypothetically, trying to send a signal across space, that's exactly where you'd send it. Because any advanced civilization would know to look there.
It's like the universal meeting point frequency.
Yeah, like if you and someone else agreed to meet somewhere without talking first, you'd pick the most obvious spot. That's what this is.
So now scientists are looking at this like, okay, it's strong, it's clean, and it's in the exact frequency we'd expect an intentional signal to be in.
And that's where things start getting uncomfortable, because it checks a lot of boxes.
Not proof of anything, but definitely not random either.
Exactly. So naturally, they try to find it again. They point the telescope back to the same part of the sky. They scan again, and again.
Nothing.
Yeah, nothing. And this is the part that really messes everything up. Because in science, repetition is everything.
If you can't repeat it, you can't test it. If you can't test it, you can't prove it.
So now you're stuck in this weird position. They have real data, a real signal, recorded, analyzed, but no data with it.
And science loves data.
Exactly. Because if you're not sure what you just detected, then the best thing to do is to look for it again. But when you try to look for it and it's gone, you're stuck.
It's like getting one message and then the sender just disappears forever.
Yeah, like imagine your phone lights up, you get a message, you read it, and then the number just doesn't exist anymore.
You'd be thinking about that for a while.
Exactly. So now they start looking at the shape of the signal itself. Because even if you can't find it again, you can still analyze what you already have.
And the shape matters because random noise doesn't behave cleanly.
Right. Noise jumps around. It's messy. It spikes randomly. But this signal? It rises smoothly, peaks, and drops. Almost perfectly.
Which is exactly what you'd expect if the telescope was passing over a fixed point in space.
Meaning the source wasn't moving wildly. It wasn't bouncing around. It was stable.
And that makes it even harder to explain, because now it doesn't look like interference, and it doesn't look like random space noise.
So then the next question becomes, could it be something natural?
Like a star, a cloud of gas, or some kind of unknown cosmic event.
And scientists look into that too. Because space does weird things. There are signals we don't fully understand even today.
But here's the problem. Most natural signals aren't that narrow and that clean.
Yeah, they're usually spread out across multiple frequencies. They fluctuate. They're messy. They don't follow a perfect rise and fall pattern like this one did.
And they definitely don't produce signals that are perfectly aligned with the hydrogen frequency.
So now you've ruled out Earth. You've questioned natural sources, and you still don't have a solid answer.
Which is honestly the worst case scenario for scientists.
Yeah, because now you're stuck in that middle zone, where it's not explained, but it's also not provable as anything extraordinary.
And that's where theories start forming.
Exactly. Because when you don't have answers, people start filling in the gaps.
Some of those ideas are grounded, some are a little less grounded.
Yeah, and this is where things start getting really interesting. Because now we're moving from what we know to what we think might have happened.
And that's where the wow signal goes from being a scientific mystery to something way bigger.
Because depending on how you interpret it, this could be a rare natural event, a signal we just don't understand yet, or something that was never meant to repeat.
And that last idea, that's the one that keeps people thinking about this for decades.
Because if it wasn't meant to repeat, then maybe it wasn't random at all.
And that's where we have to start looking at the theories.
So now we're in that zone where there's no clear answer. And that's where theories start showing up.
Yeah, because when something doesn't make sense, people try to make it make sense, even if the explanation isn't perfect.
Yeah, because when something doesn't make sense, people try to make it make sense, even if the explanation isn't perfect.
So let's start with the most grounded one, natural sources.
Right. The idea here is that something in space, like a star, a cloud of gas, or some kind of cosmic event, produced the signal. And we just don't fully understand it yet.
Because to be fair, space is still full of things we don't understand.
Yeah, like we're learning new stuff all the time. New types of signals, new patterns, new behaviors. So it's not impossible that this was something natural.
But here's the issue. Most natural signals aren't that clean.